So you should see a little recording button came up. So you're being recorded now. So these 3 wires, and we're going to say,
Honeymoon Bay too.
so we're going to say these are 2 ohms each. Okay. And let's say these guys are, I'm going to give you amperage here. Let's say this is 10 amps and this is 14 amps. So my question for you is, will we have 120 volts at this load here?
No.
And why is that?
Volt drop in the line.
Yeah, I gave you the hint already. There's going to be some voltage here, some here, and some here. Now this is where polarities are going to come into effect for us. So we know we have, if I do this the same way, I'm going to put the amperages up here now. We got 10 amps here, 14 amps here, 14 amps here, and I'm going to do this down here, 10 amps here too. Sorry, okay. So now if I know these are the amps. So I know my amperage. I can calculate my amperage in this node here. I got 10 cars coming in, 14 cars leaving. Means I have to add some cars here. And we got to add 4, right? So we follow this back here. Going through the resistance of this line, we have 4 amps on here. So I can put my 4 amps in here. Sorry, that's actually this guy here is down here. I missed. He's down here. He's down here. More for me to remember that than you. That means I'm going to have 8 volts of drop across here. And I'm going to have, well, that's not right. Wish I wasn't recording this now. I can't multiply. How many watts would that be, that wire?
32.
Yeah, so 32 watts. So that's much heat that wire is producing is 32 watts. Not a lot, but some. So now if I follow this 10 amps through here, I've got 10 amps on that. And so my voltage drop across that line is 20 volts. And what's the wattage produced by that line?
$200.
Yeah. So there's a lot of heat produced there in this circuit. And down here, so I've got 14 amps flowing through here. So I can write down my 14 amps through here. Let's keep the same. 28 volts. Does anybody want to crank out their calculator? 283.
390.
390.
392.
Sorry, how much? 3 what?
392. I don't know. Did I do that wrong?
92? Okay. Now, the next thing is, now that we've solved all these values, we can't solve here yet because we don't know the polarities inside the circuit. So we know that this is going to be negative, and this is going to be positive. This is positive, and this is negative. And we know that the current is flowing this way here because it's flowing that way. So that means that current gives polarity. So this means that this part here is going to be negative, and this is going to be positive, and this is going to be negative, and that's going to be positive. And the same thing down here, current's coming this way. So this will be, oops, this will be negative, and this will be positive. And what's really important is this resistor right here, the current's flowing this way. So this will be oops. So we're going to walk the circuit to find out what the voltage is across here. So if I want to know the voltage across this R1 here, I can start here and walk around this circuit till I come to this value here and just put it as a mathematical formula. So I'm going to come up, I'm going to start here, I'm going to walk down. I come across a positive value first. So it's positive, positive 8 volts. I'm going to walk across here, come up here. I've got a positive 120. I didn't tell you that it was 120, but we can assume it's all 120, 120. Oops, okay, well that worked. So actually, maybe it's good. There we go. And then we're going to come to this here, and here we've got a negative 20 volts. And so plus 8 plus 120 minus 20 is equal to what?
108.
Nice. And we do the same thing down here, and it doesn't matter which way we walk. Just that we started here, and we ended up with a positive 108. If we started here and walked this way, we would have reached with a negative 108. So let's continue walking down this way here. So we come down here, we come to a negative 28 volts. Come along here, we come to a positive 120. And come across here, and we've got a negative 8 volts. And so minus 28 plus 120 minus 8 is equal to what?
92.
And so from that, we can find out our resistances. I can do the math here for you. 10.8 ohms here. And we got 1080 watts here.
Is that 92 or is that 84?
I didn't do the math.
I
I
think
didn't
it's
confirm the 92. Minus 28 plus 120 minus 8. I got 84.
I got 84 too, yeah.
Yeah, I botched it. My bad. Good catch.
All right. Okay, and the resistance, 84 divided by 14.
Six.
Wow. Here's my math for you. And wattage, 84 times 14.
1286.
1286.
1288.
Sorry, what again? 12.
1,176.
Mm,
1,176.
Yep.
oh, that's right. That was the other one.
1,186.
776.
Okay. So we're going to figure out what the, so this one here, no resistance in the line, so it's going to be a simpler circuit. So we're going to have 120 volts across here. And we can figure out our current. So we can just do that to start with, just saying, okay, I've got 3,600 watts on R1. And 1,200 watts on R2. Is anybody still drawing this? So now, if our neutral breaks here, and we could have figured out here we're going to have before the break 20 amps flowing that way. But now after the break, what do we have? Without this in here, then what we have is just a 240 volts across both of them. So now it becomes a series circuit. So really what I need to do first is do a little tower of power for everything. We got 240 volts across all of that. And does anybody want to give me what the total resistance of this circuit is?
Is it 16 ohms?
Yeah, it is 16 ohms because it's series circuit, so we're going to add these two together. And from that, we can get our current.
I got 15 amps.
That is correct. And if we wanted to, we could figure out the total wattage of that circuit is
3,600.
And before the break, we had 36 plus 1,200 was 4,800. So now the one thing that doesn't change when we change the voltage is what in a circuit?
The current.
Nope.
No. The resistance.
Yeah, these guys here, right?
Yeah.
They're going to stay the same. So we can break this down. We got 4 ohms here and 12 ohms on this guy. But they're carrying the same current now, aren't they?
Which is what?
This is our 15 amps here,
Mhm.
That's the 240.
right? That's what's going through both of these. So we bring this 15 amps over here, 15 amps over there, and now we can find the voltage across each one. So across R1 is how many?
60.
Yeah, 60 volts. And the wattage it's producing is
900.
900. And down here, the voltage 12 times 15.
160?
180.
Oh, 180.
And the wattage it's producing.
2700.
So you can see that this poor little guy here is, doing a quarter of the wattage. So this is your toaster. It's not going to be working very well. And this poor guy here is only designed to run 1200 watts. And now he's producing 2700 watts. So
So it's going to burn out.
it's going to burn out, yeah. So if you have, a lot of you guys, just a second, I'm just going to pause this for a sec.